Okay, hi everyone. So today, as part of the Foundation Mastery Method, we will be talking about integration and Riemann sum. Let's look at another example, which is in the form of a differential equation. This is telling us that dx over dt is 9t to the negative 1 minus 5t plus e to the t. Now, to start off, we can multiply both sides by dt, and we're left with dx equals 9t to the negative 1 minus 5t plus e to the t dt. Now we can take the integral for both sides. Remember that the integral for d to the x is simply x, and we can also write this as x of t since t is our variable here. And so we would rewrite this as x equals 9 log of t minus 5 over 2 t squared plus e to the t plus integration constant c. And to arrive here, we simply used our power rule and natural log rule as well. Now that we have it in this form, that's our final answer. And let's look at one last example. So here we notice that we have two terms that are being multiplied by each other. Similar to the division problem, we do not use a product rule. Rather, we multiply this. So for this, you can either use foiling or distribution. And here we've used distribution to multiply 9x by x minus 3, and then we do plus 3 times x minus 3. You can simplify this to obtain 9x squared minus 24x minus 9. And so we've rewritten our function in this form. And now this is pretty straightforward. We can simply use the power rule, and we get 3x cubed minus 12x squared minus 9x plus the integration constant. Now we talk about definite integration or accumulation. So given a function y equals f of x, the integral can be written as uppercase f of x, and this is what we call the accumulation function since we're adding the areas together. So using this accumulation function, we can come to definite integration. So definite integration is where you have a definite interval over which you want to find the integral. So here we have a function, and we've been given the interval to 2, 4. So we can rewrite this as integral of f of x dx, and we write the lower bound 2 and the upper bound 4. This is the same as writing uppercase f of 4 minus uppercase f of 2, and this is our accumulation function. And this right here is what we call the fundamental theorem of calculus. And to illustrate this, here we have our graph, and notice that we only want the area of this highlighted chunk. And so to do this, we can find the area under everything after 4 and then subtract it by the area of everything after 2. It is called a definite integral, and this shows the net area under the graph. Now we can simply solve this using the rules we know from before. So we rewrite the function with our bounds, and we start by solving it using the power rules. Now what we have here is our accumulation function. Now to account for the bounds, we simply substitute x by 4, solve the equation, and substitute x by 2 and solve the equation, and then we subtract the 2. So you will be left with a final constant, which in this case is negative 44 over 3, which you can simplify to negative 14.667. Now let's talk about Riemann sum. So let's say you have a function f of x equals 4x squared minus 4 on the interval 2, 8, and you have two divisions. That's what n represents. First, we can find delta x, which is our step variable. To do this, we subtract the upper bound minus the lower bound and divide it by the number of divisions. So we get delta x equals 8 minus 2 over 2, which is 3. So we start at 2, since that is our lower bound. So that is x of 0. And then our next step is we add 3 to that number, so we get 5. And then we take one more step to get 8. So these are our points, and we have two divisions. Now to find the left Riemann sum, we take two divisions starting from the left hand side. So we have delta x times f of 2 plus f of 5. So we substitute x to be 2 and 5, and we add them together to get 348. Now to find the right Riemann sum, we once again take two intervals, but towards the right. So in this case, our intervals will be at 5 and 8. So we're left with delta x times f of 5 plus f of 8. And then we can simplify this to get 1068.